In this video, we're going to be talking about graphing rational functions. A rational function is an algebraic fraction such that both the numerator and denominator are polynomials. So let's look at an example. Y equals 2 divided by x minus 1, all minus 1. In order to graph this, I need to first identify my vertical asymptote. The vertical asymptote is going to be a value where the rational function does not exist. From what we know about asymptotes, asymptotes are going to be a line, either represented as x equals or y equals, depending on what type of asymptote it is. And for vertical, a line that will be going up and down would be an x equals line. So in order to find this value, I take the denominator and set it equal to 0. And then I find what value of x makes this statement true. By adding 1 to both sides, I get x equal 1. X equals 1 is my vertical asymptote. I can graph this asymptote using a dotted line. And with rational functions, we're going to have a lot going on in our graphs. We want to make sure that we are labeling the different asymptotes. My second step is to find the horizontal asymptote. In order to do this, I need to think back to what I know about function transformations. Looking here, we see that this minus 1 tacked on at the end of the equation will cause the whole function to be shifted down 1 unit, making this horizontal asymptote y equals negative 1. And horizontal asymptote shows us that the line's going to be going left to right, making it a y equals line. So at y equals negative 1, I can graph this asymptote, once again using a dotted line and labeling it. My third step here is to find the x and y intercepts of my graphs. So let's start with the y-intercept. The y-intercept is where the function will cross the y-axis when x is 0. So in order to find this, I just need to substitute the value of x as 0 and then solve. Here I get 2 divided by a negative 1, all minus 1, which when I evaluate this gives me a negative 3. So my y-intercept would be 0, negative 3. And then in order to find my x-intercept, I would set y equal to 0 and solve for x, adding 1 on both sides. And then we get down to here. So I added 1 on both sides. And at this step, we need to think of 1 being represented as a fraction 1 over 1, where we can then cross multiply to solve. And I'd add 1 on both sides, and that would give me the intercept 3, 0. And so I can plot these intercepts at 3, 0, and 0, negative 3. Lastly, I want to find values using these different intercepts. So what we know about rational functions is we will have 2 what's called branches. And so I want to use these intercepts to create a table of values. So this value when x is 0, y is negative 3, I want to find the value at negative 2 and negative 1. And then using this intercept, I want to find the value at 2 and 4. And I would do this by substituting these values into my equation for x and solving. So 2 divided by a negative 2 minus 1 would give me a negative 5/3. 2 divided -1 minus 1 minus 1 would give me a -2. 2 divided by 2 minus 1 minus 1 is going to give me 1. And then 2 divided by 4 minus 1 minus 1, 2/3, would give me a -1/3. And so I'm going to plot these points. At -2, I have the value -5/3. And then at -1, I have the value 2. You kind of can see the curvature of this branch here. And then at 2, I have the value 1. And at 4, I have the value -1/3. Once again, you can kind of see the curvature of this second branch. And so then finally, I would just fill in these points and run my function along the lines of the asymptotes. Once again, the definition of an asymptote is going to be what value the function does not exist at, so our functions will never cross these asymptotes. So what I meant by earlier is these two parts of my function are called branches. So let's try another example. The example -4 all over x plus 2 minus 2 equals y. So my first step here would be to find the horizontal or the vertical asymptote. So I take the denominator, set it equal to 0, and when x is equal to -2, the denominator goes to 0, so this is the vertical asymptote. Second step, I'd find the horizontal asymptote, looking at the function and knowing what I know about function transformations. I'm going to be shifting down 2 units. So y equals -2 would be my horizontal asymptote. And then my third step, to find the x and y intercepts. So to start with the y-intercept. And I get 0, -4 as my y-intercept. And then set y equal to 0 and solve for x to find my x-intercept. So adding 2 on both sides, putting 2 over 1 so that I can cross multiply. Be very careful when we're cross multiplying here to make sure we're distributing the 2 to x and 2. And so I can plot my x and y intercepts. And then using those, I'm going to make a table of values. I'm going to find the values at -3 and -2, and at -1 and 1. I'm picking these x values arbitrarily based off of the intercepts. drew my intercept incorrectly. Notice when I plug in the value -2, since it was an asymptote, -2 plus 2 would set my denominator equal to 0, so this value would be undefined. And so at -3, I have a value at +2. And at -1, I have the value at -6. And at 1, I would have -4/3 minus 2, which is going to go right below here. And so notice when I graph these branches, unlike the graph from before, the branches are reflected over the x-axis. This shows the transformation that negative with my numerator of the fraction portion of the rational function shows the effect. So what's important to remember here is when you have the negative out in front, it is going to be an x-axis reflection even with a rational function. Thanks for watching.